Hello and welcome back to this ElasticSearch tutorial. In this part, we'll build into what we saw in the last video about querying for information, and we'll look into ElasticSearch aggregations, what they are, different types of aggregations that exist, and how to use them. An aggregation, according to the ElasticSearch documentation, can be seen as a unit of work that builds analytic information over a set of documents. What this means is that an aggregation is basically information about the set of documents that you're searching for. For example, if you're searching for different job types, then one aggregation could be how many of a specific type there are with the parameters that you search by. Or if you're searching for prices from a product database, an aggregation could be what the highest price is or what the average price is. This is what analytic information from your set of documents means. Aggregations can be one of 4 types in ElasticSearch. They can be bucketing aggregations, metric aggregations, matrix aggregations, of which there's only one, or there can be pipeline aggregations. This is just a way to classify what an aggregation does. For example, from the previous examples that I mentioned, getting the sum, getting the max price, or getting the average price from a product index would be a metric aggregation. But getting how many jobs of a specific type there are would be a bucketing aggregation. Bucketing aggregation basically work by grouping documents within a bucket. Each bucket has some criteria associated with it, and then ElasticSearch will determine whether the document that you search for falls in each specific bucket. ElasticSearch not only creates the buckets, but also computes how many documents fell into or are part of each bucket. If you're familiar with relational databases, think of this as similar to a group by clause in an SQL query. Bucket aggregations basically group the documents in a very similar way. Let's look at how this works. This is the same query that we've used during the last video. It's searching for all documents where the description field contains the word test, and it's boosting any documents from the test index by a factor of 2. But now we've also added an aggregation section, and first we're gonna look into the bucketing aggregation. First, we generate a label for this bucket. In this case, I chose to call my aggregation unique users, and I'm using a terms aggregation. For this, I'm aggregating for a field, the user field. So if I run this query, you will see that I not only get all the documents that I got just from running the query. In this case, all 3 documents that have a description field that contains the word test. But then I also get an aggregation section where my aggregations will show up. First, and the one that we're looking into now, I have the unique users aggregation. And here I have the buckets that were calculated automatically by Elasticsearch. Here I can see that out of the 3 documents that I have 2 unique users, one called Victor and one called Tom. And I also get how many of each type of each bucket appear within my search. In this case, I have 2 documents with user Victor and 1 document with user Tom. If we go to our query, you can see that indeed I have 1 Tom user and 2 Victor users. Other examples of bucketing aggregations would be histograms, IP rangers, or range aggregations, among others. Next, we have metric aggregations. Metric aggregations compute new values based on the values already present in your query. Some examples of that are average, max, min, or sum of some fields within your query. Any numerical aggregation would fall under metric. Let's give this a try. In this example, because my documents have an age field, I'm going to calculate the average age within my documents. I'm going to create a new aggregation called avg_age, and I'm going to call an average aggregation on the age field. If I go to my aggregations, I can see that I have an average age aggregation with a value of 38. Let's see if this adds up. The Twitter index document doesn't have an age, so that one's discarded. The Tom document has an age of 45, whereas the Victor document has an age of 31. So if we add those two and divide that by 2 to get the average, I get 38, which is what average age aggregation is showing up. Then we have the matrix aggregation. This is an aggregation from Elasticsearch that produces a matrix with some metrics for the fields that were aggregated. However, keep in mind that this is classified by the Elasticsearch team as an experimental functionality, which may be changed or removed from a future version. Regardless, let's see how this works. In my query, I'm adding one final aggregation. I'm calling it statistics, and I'm calling a matrix stats aggregation on the age field. And then, if I go to the results, I can see that I have a statistics aggregation. In this case, I get a doc count of 2. This is because only 2 of my documents actually have the age field set. Then, I get an explanation of each field included in this aggregation. In this case, you can see that the field is called age. It has 2 documents. The mean is 38, which matches the previous aggregation that we've done. It has a variance of 98, a skewness of 0, a kurtosis of 1, and a covariance of 98, as well as a correlation of 1. So if you need more in-depth information of our statistics, you can use this on your fields. Finally, we have the pipeline aggregations. These are not specific commands, but rather these are aggregations being applied not to a document field, such as the user or the age like we see today, but instead applied to the results of other aggregations. For example, imagine that you have different users and you get a bucketing aggregation showing how many times each user has posted a page, similar to the example that we did just now. In that case, you might want to find out which user has the most mentions, so you could get a max aggregation not on that field, because none of the documents within our search say how many times the field appears. Instead, you could apply a max aggregation on the bucket aggregation that groups documents via the user field. So this is how ElasticSearch aggregations work and how they can improve and enrich the queries that you make. In the next video, we'll learn about how to visualize the information using another tool from the ElasticSearch, or rather Elastic ecosystem, which is called Kibana.